latent heat capacity. The word latent means that hidden, unseen. So actually this case is coming whenever there is a change of state for the substances taking place. For example, a solid when it is converting into liquid, and also a liquid when it is converting into its vapor state. The heat energy given to it is not seen outside. So where does it go? Or how much is the heat energy required for that conversion? It's all relating with what you call specific latent heat capacity of the substance. So for example, let us take a situation where I am taking pieces of ice cubes, okay, in a vessel, and this ice cubes, let it be at 0 degrees Celsius. This ice cubes taken, and a thermometer is inserted into this. It's a thermometer, and the thermometer reads 0 degrees Celsius at the moment. That means the ice is at 0 degrees Celsius. Now I start heating this vessel, and as I go on heating the vessel, what I could see is that ice fluid is melting. Ice starts melting, and the melting process is continuing as continuously it is absorbing heat. And what the other thing to be noted is that the thermometer reading is still 0 degrees Celsius itself. So you are continuously heating the ice cubes, ice is melting, but thermometer reading stays the same. And it stays the same 0 degrees Celsius till the whole ice in this vessel is melting completely and converting into water. Okay, so melting of ice is taking place at constant temperature. There is a temperature of melting of the ice. Okay, so there comes a quantity called latent heat of fusion. That is, for melting, an amount of energy is required. That energy is not seen outside. It is not used for heating the ice, but it is used by the molecules of ice, and they are getting free from each other. Okay, to release the molecular bonding, and the solid converts into water. So if I define it for 1 gram of ice, okay, there we get a quantity called specific latent heat of fusion, or specific latent heat of melting of the solid. So the specific latent heat of fusion of solid can be defined as the amount of heat energy required to convert 1 gram of solid into its liquid state at the melting point of the solid. That is, it is the amount of heat energy required to convert 1 gram of solid at its melting point completely into its liquid state at the same temperature. Okay. So if we calculate that for ice, we get the specific latent heat of melting of ice is equal to 80 calorie per gram. This is for ice. Okay. So what this implies is that to convert 1 gram of ice at its melting point, completely into water, it takes 80 calorie of heat. Okay, like this, each solid will be having its own specific latent heat of fusion. Now, as I go on heating this converted water, right? Ice is now fully converted into water. Okay. As I go on heating this water, see, water is getting heated, and therefore this thermometer reading goes on increasing, and it reaches 100 degrees Celsius. By then, the water in the beaker starts boiling. Okay. Now, if you go on heating further, the boiling water is getting heated, and you can see the amount of water in the beaker is going on decreasing. That means water is gradually getting converted into water vapor and goes off. Until the whole water converts into water vapor, the reading in the thermometer remains as 100 degrees Celsius itself. So, conversion of liquid into its vapor state also taking place at the constant temperature, and it is known as an isothermal process. So, at that state change, we can define a quantity called specific latent heat of vaporization of the liquid. Okay, right? To define this one, it is the amount of heat energy required to convert 1 gram of the liquid at its boiling point completely into its vapor state at the same temperature. And if we calculate the specific latent heat of vaporization of water, you get LB for water is equal to 540 calorie per gram. What this means that for 1 gram of water at 100 degrees Celsius to be converted into its vapor state completely, it requires 540 calorie of heat. That means if you take 1 gram of steam at 100 degrees Celsius, it is having a heat energy that is equal to 540 calorie. Okay. Now, therefore, it is having a very high energy here associated with the steam, and therefore the what do you call the damage caused by the steam is more severe than that caused by the boiling water. Because for boiling water, 1 gram of boiling water will be having an energy Q equal to 1 gram into 1 calorie per gram per degree Celsius into 100 degrees Celsius. That is 100 calorie only. Okay. So this is the energy associated with the 1 gram of boiling water, but this is the energy associated with the 1 gram of steam. That is more than 5 times the heat energy is. So the burning caused by steam is more severe than that caused by the boiling water. So when you are dealing with the steam experiments, be very careful about these facts.